Alright, hey guys, welcome to 4.7 day 2. Today we're using the discriminant. Our essential question, how do you use a discriminant to determine the number of solutions to a quadratic equation? We're going to talk about it, and then we're going to basically use our quadratic formula a little bit in working with problems. Alright, so we can determine how many real number solutions that we have using the discriminant. And what the discriminant is just this part of our quadratic formula. Okay, so it's just the b squared minus 4ac part. And all that tells us is how many real numbers we're going to get for answers. Now, you could have imaginaries. Okay, if this number in here ends up being a negative, we're going to have imaginary answers. And so using our discriminant, we can tell how many times, basically how many times it crosses the x-axis. All right. So for in this case, if we do b squared minus 4ac and is bigger than 0, that means that we're going to have two solutions. All right, so we're going to have two solutions. And our graph would look, just something, just kind of winging it here. It would look something like this, where it crosses the x-axis twice. We're going to have two real solutions. It's going to cross twice. Okay. If it equals 0, that means we're going to have one solution. And basically what that means is that our vertex is going to be on the x-axis somewhere. So maybe we'll just say it's going down. Okay. It could also go up. But the key is that our vertex is on the x-axis. Okay, now, if whatever number you get for the b squared minus 4ac, if that number is less than 0, we're going to have no real solutions. And the key word here is real solutions, because there are solutions. We have two solutions, guaranteed solutions. The only thing is, sometimes they're imaginary. And so what our graph will look like is maybe it's like down here, or something like that, where it's not even crossing the x-axis. It could also be positive and be up here or whatever, but the key is that it won't cross the x-axis. Alright, so we're going to use our discriminant. Remember, the discriminant is the b squared minus 4ac part of our quadratic formula. And we're going to figure out how many real number solutions using the discriminant. Alright, so b squared, this is b, right? So we have 8 squared minus, let's put that in parentheses, minus 4, a is negative 2, and c is negative 5. Okay, and we just basically solve this. So this is 64, 8 times 5 is 40, and it's negative 40. And so our final answer, positive 24. Oops, wrong one. Now 24, if we look back at our list, our answer is greater than 0, right? This is greater than 0, and so how many real solutions do we have? We have two real solutions. Two real number solutions. All right, now this one. First we need to get everything on the same side, and so x squared, we subtract 2x. Okay, and we get b squared. So negative 2 squared minus 4 times a is 1 and c is 3. Okay, negative 2 squared is just positive 4. And this is negative 12. And so we get negative 8, which is less than 0. And so here we have no real solutions, because it's less than 0. Okay, so the answer to this one would be a bunch of imaginary numbers, pretty much. All right, and our last one here, same thing. Make sure we get everything on the same side to begin with. Plus 14x, and then we're going to subtract 49. And that equals 0. Okay, so I'm still in quadratic formula mindset here. Not negative b, just b squared. Let's actually put our numbers in. So 14 squared. I encourage you to use parentheses all the time, even if it's positive, just to get, it's a good habit to get into. 4a is -1, c is -49. All right, 14 squared, let's grab a calculator here. 14 squared is 196. Okay, -4 times -1 times -49 is -196. Okay, and so we end up getting 0 and 0 equals 0. And so if we look back at our chart, what does that mean? It means we have one solution. So our vertex is on the x-axis. One real solution. All right, now some word problems to get us thinking here. We're not going to use the determinant as much, although we can. And so if a rocket is launched from the ground with an initial velocity of 150 feet per second, and then it's modeled by that function, it models the height that the rocket is at based off of t time. And basically our question is, will the rocket reach a height of 300 feet? And explain your answer. Now, there's a way to use the determinant here. And we'll do that one first, and then I'll show you how I would do this problem. But since this, not determinant, discriminant, I'm sorry, determinant is a whole nother thing. So if I say determinant in this lesson, I mean discriminant. Sorry about that. We're going to use the discriminant first. So our height is 300 feet, right? And so we plug in 300 for our height, -16t squared plus 150t. Okay, and then just like all the other problems, we subtract 300 to get it on the same side as everything else. So -16t squared plus 150t minus 300. And then we use the discriminant, not the determinant, the discriminant. And we do 150 squared. Parentheses are always good. Minus 4a is -16. C is -300. Calculator time for all this stuff. And what you're going to end up with is 22,500. And then all of this multiplied together is -19,200. And so we're left with 3,300. That number is bigger than 0. And so the answer here is yes, it will. Will the rocket reach a height of 300? Is greater than 0? Yes. So if the determinant turns out greater than 0, our answer is yes. Now, this is how I would solve the problem. Okay, so if you need to write this down, pause the video. Otherwise, I'm going to start over and tell you how I would do it. All right, so how I would do it is, our rocket launches up, reaches a vertex height, and then comes back down, right? I would just find the vertex height, and if it's greater than 300, then I know that it had to have reached a height of 300. And if this is less than 300, I know that there's no way the rocket could have gotten up to 300 feet. And if you remember back a few sections, we did this by doing -b over 2a. That's how I would do this problem. And so let's just do -b over 2a. I don't need to plug in anything. I'm just going to use this equation, -b over 2a. So we got -150 over 2 times -16. Okay, which turns into -150 over a -32. And that ends up being a decimal 4.6875. And it ends there, so it does end nicely. And then if you remember, so this is how many seconds it's going to take to get up to this point. Okay, so from this point time 0 to here, it takes 4 seconds, 4.6 whatever seconds. Okay, now to figure out how high it is, to figure out the height, we need to plug this back into our formula. So negative 16 and then 4.6875 squared plus 150 times 4.6875, and that'll get us the max height that this rocket reached. And that height, to save you some time, that height is 351.56 feet. Okay, so the tallest it got was about 100 or 352 feet, give or take. And so to answer the question, will the rocket reach the height of 300 feet? Yeah, it will. It'll reach it right about here, and then it'll also reach that height right around here as it comes back down, right? And if we go back to what we did with the discriminant, our number 3,300 was bigger than 0, and so when it's bigger than 0, it has two solutions, and so our rocket, on a graph, it crossed that 300 threshold twice. And this picture kind of explains it. It got all the way up to 352. On the way, it hit 300, and then on the way back down, it hit 300. And so that's how we use the discriminant to figure it out. Yeah. Now our last problem here. Try to do it pretty quickly. I'll probably pause the video here now and again. Okay, batter strikes a baseball. This is the equation that models the path of the ball, so it goes like that probably. Okay, where x is the horizontal distance. Okay, so how far it traveled, this is x, and then y is the height, and so from here to here, that's, we're talking the y coordinate point there. How far from the batter will the ball land? Okay, so we're looking for this point. And we're on the answer to the nearest tenth of a foot. Okay, well, our quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac, right? All over 2a. Okay, so we can figure out our x. Okay, so we'll figure out this point and this point, essentially. Okay, and obviously we'll be able to tell which one we're looking for. We're looking for this one right here. So we'll just have to use our brains when we get to the end of this problem. All right, so let's set it up. Pause the video. You set it up, I'll set it up, and then we'll come back together. All right, so I plugged in my numbers. Make sure you check and make sure you did everything correctly. And then we just keep going here. So we have negative 0.7 plus or minus the square root of 0.49 plus 0.07 when you do your calculator work. And then this is all over negative 0.01. Okay, and then we just keep on going with it. So x equals negative 0.7 plus or minus the square root of 0.56 all over negative 0.01. Okay, now this is not negative, so we are going to actually calculate it out because it's a real world problem. We need actual numbers here. And so, grab your calculator, do the math of it all. Feel free, it says round. Let's not round all the way down to tenths right now. We'll leave it at 0.75 all over negative 0.01. Okay, now here's where we split it. So negative 0.7 plus 0.75 divided by negative 0.01. And then our other one here is negative 0.7 minus 0.75 all over negative 0.01. Okay, do the math of it all, and we'll come back together. All right, so you calculated it out with your calculator. One of them got you negative 5 feet. The other one 145 feet. And let's just use our brains here. Which one is it? It's 145 feet, right? So that's where it'll land. And the reason negative 5 is like it is because the batter is off the ground, and so the parabola before it hits the batter, the parabola has already been going for a while.